Hi, thanks for joining me. Over recent videos, I've been experimenting with what type of content you guys might like. So today I'm doing another kind of experiment. I'm going to be showing you a maths-based magic trick. So I'll show you the magic trick, and it's kind of like an interactive one, so you guys have to get involved as well. And then once I've done it, if you want to find out how it's done, I'll explain all the maths behind it, and that will essentially explain why the magic trick works. So without much further ado, let's get stuck in. Okay, so as I said, this is kind of an interactive magic trick, so make sure you have like a pen and a piece of paper handy, and maybe a calculator if you need as well. But basically, what I'm going to get you to do is generate a 3-digit number. So the way I'm going to get you to do that is firstly just to choose any 3 whole numbers between 1 and 9 that you want, so any 3 digits essentially, between 1 and 9, and they all have to be different. So you could choose, 2, 3, and 6, for example. And then once you've got your 3 numbers, I want you to shove them together in any order you want to make a 3-digit number. So if I did choose 2, 3, and 6, firstly, that's valid because they're all different. And then I can shove them together in any order I want. So maybe I could choose 623 to be my 3-digit number. Great. So you'll have a 3-digit number. Then what I want you to do is just reverse the order. So 623, let's reverse it. So we get 326. Okay, so now you're going to have 2 3-digit numbers written down, and one of them is going to be bigger than the other. In this case, this number is bigger than this one. What I want to do is do the big number and then subtract the smaller number. So in this case, I get 623 minus 326. So you do that with your numbers, do the big number minus the small number, and then what you'll be left with is either a 2-digit number or a 3-digit number. Basically, we want it to be a 3-digit number. So if it is a 2-digit number, say you get, 46, for example, the way we're going to make it a 3-digit number is just by putting a 0 in front here. Okay, so it doesn't really change anything, but we're just putting a 0 in sort of the hundreds column. Okay, so we now have a 3-digit number, or sort of an artificial 3-digit number in my case. Okay, and then what I want you to do is reverse the digits of that. So in this case, I get 640, like so. Okay, so let's just quickly go over what we did. We had a 3-digit number, we reversed the order, we did the big one minus the small one, and that would give us some new number. Which is either a 3-digit or a 2-digit, but if it's 2-digit, we make it into 3-digit by putting a 0 at the front. Okay, then we take that number and reverse it like so. So now we've got 2 3-digit numbers here. Then what I want you to do is add those 2 3-digit numbers together. So you'll have now, in my case, 6 plus 0 is just 6, 4 plus 4 is 8, and 0 plus 6 is 6. Okay, so you'll be left with a number, in my case 686, because you're adding together 2 3-digit numbers. One of them is going to be it's either going to be 3 digits or 4 digits, depending on what your number is, but you'll be left with a number. Okay, cool, and that's kind of the end of the work that you have to do. But one thing I actually didn't mention was before I started filming, I actually made a little prediction about what number you'd have written down here. I've got 686, but I made a prediction on what you would have written down. Now, remember, I have no idea what number you initially chose. It could have been any 3-digit number, essentially, and all you've done is follow these steps, and you've ended up with either a 3-digit or a 4-digit number. But I made a prediction before this all started, which is pretty insane if it's correct, because the odds of that happening are quite small. But I made a prediction, and I had it written on this piece of paper, which has been behind this whiteboard this whole time. And I reckon your number was 1089. Was I right? I think I was right. I was right, wasn't I? Yeah, so that is the cool magic trick. My showmanship perhaps could have been a bit better, but that's how it works. So I'm pretty sure your number is 1089, at least if you've done this properly, not 686 or anything like that. And now let's get stuck into why exactly this magic trick works. Okay, so let's just get stuck into why this works. So initially, what did I get you to do? I got you to choose a 3-digit number where all the digits were different. So we have a 3-digit number, and I'm just going to write that as ABC, like so, and then concatenated like this. So when I write ABC, normally that just means you multiply A, B, and C together, but when I put this bar on top, that means concatenated. So these are just some digits between 1 and 9, and I'm just shoving them together. So for example, if A was say 3, B was 6, and C was 1, then this guy here wouldn't be 3 times 6 times 1, it would just be 361. So that's all this sort of bar notation means. Okay, so let's just get rid of this. So you chose some number, ABC, and then what I got you to do was reverse the order of that number to give you some new number, CBA, like so. Okay, so ABC and CBA. ABC Remember, each of A, B, and C are digits between 1 and 9, and we can actually write this thing here as 100A plus 10B plus C. Okay, and the reason this works, or the reason I can write it like this, if you just go back to our example, if A was 3, B was 2, and C was 1, then this guy here would be equal to 321, which is, of course, 100 times 3 plus 10 times 2 plus 1. Okay, so this number here is in the hundreds column, hence we multiply it by 100, so 100 times A. This B is in the tens column, so we get 10 times B. And this C here is in the units column, so it's just C. Okay, so this is sort of an example to exemplify that. Okay, so ABC concatenated is just 100A plus 10B plus C. But then when we reverse the order, we get CBA concatenated. Now, what number is this? Well, this again is just 100 times what's in the hundreds column, so 100C plus 10B plus A, like so. Okay, now we have two numbers, and the next thing I got you to do is take the bigger number and subtract from the smaller. We don't know whether A or C is bigger, so we're just going to essentially assume that A is bigger and do this number here minus this number. Okay, and now one key thing is, remember at the start I got you to ensure that A, B, and C are all different, but in particular, I mean B can be the same as A and C, but in fact A and C are the only ones that I need to be different, because otherwise when I do this number minus this number, I get 0. And we don't want to get 0, so we do this number minus this number. 100A minus 100C is just 100A minus C. 10B minus 10B, nicely that just cancels. And then C minus A is the same as minus A minus C, like so. Oh, sorry. Minus A minus C. Now, here we can just factor out the A minus C, and then we're left with 100 minus 1, which is just 99. So we're left with 99 times A minus C. Now remember, this is if A is bigger than C. If C was bigger than A, then we get the same thing, but here we just have C minus A instead of A minus C. So a way we can get around that is just by putting modulus signs around this thing here. So when we do the first two steps of this magic trick, we end up with 99 times A minus C. The magnitude, sorry, of A minus C. Now remember, A and C are just numbers between 1 and 9. So in particular, when we look at their difference, it's going to be some number between minus 9 and positive 9, and not 0 in particular as well. So it's so when we take the magnitude, then it's going to be some positive digit, so some number between 1 and 9. Okay, so we don't actually care what A minus C is, we're just going to label this number here M. So what we're left with is 99 times M. Now M is just some number in the set 1, 2, 3, all the way up to 9. So a positive integer between 1 and 9 inclusive. Okay, so that's a long-winded way of saying that once we've done the first two steps of this magic trick, what we're left up with is 99 times M, where M is some small positive integer between 1 and 9. Okay, let's move on to the next step of the magic trick. Let me clean up the whiteboard and we'll continue. Okay, so from the last step of the magic trick, we ended up with 99 times M, where M is just one of these positive integers here. And on the side here, I've just written down the first few multiples of 99. So we have 99, 198, 297, 396, all the way down to, in the case where M equals 9, 9 times 99, which is 891, like so. Now hopefully we can sort of see a pattern. So if I just perhaps write down what M is in this case, this is M, and then this number here is 99M. Draw a little table like this. Okay, so when M is 1, we get 99M isn't just 99, quite obvious. 2, 3, 4, and this one here is 9. Okay, so hopefully you can see that. When M is 1, 99 times 1, 99, 99 times 2, 198, and so on, all the way down to 99 times 9 is 891. Now what we want to do is write 99M in this notation before, where we have it, the hundreds digit, the tens digit, and the ones digit. And if we notice, we can always write 99M in the form, if we just look at this thing here, the hundreds digit is always 1 less than whatever M is. So M is 1, the hundreds digit is 0. When M is 2, the hundreds digit is 1. When M is 4, the hundreds digit is 3. When M is 9, the hundreds digit is 8. Okay, so the hundreds digit is always M minus 1, whatever M is. Okay, and what is the tens digit? Well, the tens digit is the middle digit, and it's always 9, no matter what we have. So I'm just going to put a comma there so it's clear. And then what's the units digit? Well, the units digit here is 9, 8, 7, 6, 5, 4, 3, all the way down to 1. Okay, so it's kind of decreasing by 1 each time. But if we notice something, if we do 1 plus 9, we get 10. If we do 2 plus 8, we get 10. If we do 3 plus 7, we get 10. Okay, so this units digit here is always 10 minus m. Okay, so if m is 1, the units digit is 9, which is 10 minus 1. When m is 2, the units digit is 10 minus 2, which is 8, and so on. So this units digit here is always just 10 minus m, like so. And again, this is concatenated, so I'm just going to put a bar there, like so. Okay, so we can always write 99m when m is one of these numbers here in this form here. M minus 1, not concatenated with 9, which is concatenated with 10 minus m. And of course, now we can write this using our hundreds, tens, and ones notation. This is just 100 times m minus 1 plus 9 times 10, which is 90, plus 10 minus m times 1, which is just 10 minus m. Like so, great. Now what happens if we expand this all out? Well, 100m minus 100, so we're going to get a minus 100 there. Plus 90 is minus 10, and then we've got a plus 10 here. So all the units actually cancel. So we got minus 100 plus 90 plus 10. So all we're left with is just the things which have m involved. So here we've got 100m, and here we've got a minus m. So putting that together, we actually get 99m. Okay, which is kind of just what we have here anyway. Okay, so that just sort of checks that we get this thing here, which is what we started with. But what we wanted to do, the sort of the final step was, we got this number here, and then we reversed the digits again. Okay, so we had 99m, which we've written in this form here, and then we reversed the digits to give us our new number, which would be now 10 minus m, 9, then m minus 1. So just taking this number here and then reverse the digits to give me this thing here, and this is concatenated. Okay, but again, I can write this in this hundreds, tens, and singles, sort of ones notation. This is just 100 times 10 minus m, plus 9 times 10, which is 90, plus m minus 1 now, like so. And if I expand this out, what do I get? Well, 100 times minus m is just minus 100m, and then plus this m here is minus 99m, so minus 99m. Okay, and here I've got 100 times 10, which is 1000, plus 90, which is 1090, and then minus 1. So 1000 plus 90 minus 1 is 1089. That magic number we had earlier, like so. Okay, and then the last thing I got you to do is add up the sort of the third and fourth numbers that you made, which were this number and this number. But notice we're doing 99m plus minus 99m plus 1089. Of course, the 99m's are going to cancel, and all we're left with is 1089. So when we add these two numbers together, we're going to get the magic number 1089, like so. Okay, so that's a pretty cool magic trick, if you ask me. It certainly would fall. It's not like the basic magic tricks where you start off with some number x, you times it by 2, you add 3, and then all you're essentially doing is reversing those operators. But yeah, it's kind of like a nice, you got to think about why it works. Cool trick. But yeah, do try it on your friends and family and let me know if they get fooled or not. And also bonus points to anyone who can tell me the name of the magician in the thumbnail for today. And if you, hopefully once someone gets it, I'll leave a link to a video that this magician has, a link to their performance. Absolutely mind-blowing. Sadly, not much maths in the video, but an amazing video. Probably one of the best videos I've ever seen on YouTube, full stop. So I'll leave a link to that in the description below once someone guesses correctly. But yeah, anyway, thanks for watching. Let me know if you enjoy these sorts of magic trick videos. I have a few sort of maths-based magic tricks, which I think would be quite cool. But again, it's only if you guys are interested. But yeah, thanks for watching. I'll stop waffling. I'll catch you in the next one. Have a great day.